योगः कर्मसु कौशलम्.
Hello my dear learners, I am Shiva Dave, an assistant professor of mathematics in CDU department of Gujarat University. My dear students, in this session, we will understand the infimum and supremum of the respective sequence. So let's start. So first thing, bounded set. Okay, first thing, what is a bounded set? For every bounded set, there is a supremum value and infimum value of the respective set. Okay. For example, let's a subset S in order field bounded if trapped between this and this limit. Okay, for lower bound and for upper bound. Okay, so let's understand these things by this graph. Okay, this and this your set. For an example, this is your upper bound and this is your lower bound. For example, we understand this thing by one example. For example, we have the sequence. Let's understand this is a sequence S equal to 1 upon n, set means 1 upon n. So infimum value and supremum value means, what is the infimum value? Means what means when we solve, means when we expand this thing, you get this 1 by 2, 1 by 3 up to so on. So what is the maximum value? Maximum value is 1. Maximum value is 1. Okay, so this is the supremum value of respective set is 1. What about the infimum value? We cannot say about the infimum value, but when you consider that the n tends to infinity, by putting the limit you get the value 0. So we can easily interpret that the value of this respective set is lies between 0 and okay. So now we understand the supremum. This is your basic example. Now understand the supremum means least upper bound. LUB. A set can have infinite upper bounds. The supremum is smallest of all upper bounds. Okay, smallest of all upper bounds. Okay, which is nothing but B0 is supremum of S. Okay. So now what about the infimum? Greatest lower bound. Here we are considering that all upper bounds means smallest. Okay. Here we consider the largest for infimum. Okay, for infimum value. Okay, so this is your B0 means infimum value. Okay. So now membership value. Okay. Let's consider that S is 1 by n, where n belongs to capital N. The elements are something this. Okay. So here supremum value is 1 and infimum value is 0. Okay. So my dear students, I just repeat one thing. Supremum and infimum value may or may not be in this set. Okay. So here 0 is not in this set. Okay. So it is also infimum value of the respective set, but it is not necessary that infimum value is always in the respective set, or either supremum value is always in the respective set. Okay. So here 1 by n never reaches 0, but it near equal to 0. Okay. Okay. Fact that means we all means in general we say that means we believe that the supremum and infimum must be in the elements inside the set. But fact is that they only need to belong to order field, not the set itself. Okay. So now, when set are bounded, when set are unbounded, sorry. Okay, means set of natural number, means natural number. Okay. The infimum value is 1. Infimum value is 1. What about the supremum value? Supremum value is not defined. Okay, supremum value is not defined. Okay. The supremum value can be considered the extended real number. Extended real number means minus infinity to infinity. Okay, minus infinity to infinity. The supremum value is infinity, but when we consider the extended real number. Okay. When you consider the real number, only real number, not extended real number. For the real numbers supremum and infimum both are not exist. Means neither supremum nor infimum exist. Okay? Because in the real number there are infinite real number. There are infinite real number. But when we convert this real line into extended real line, the supremum of extended real line is plus infinity, and supremum of extended real line means infimum of extended real line is minus infinity. Okay? So now strategy 1, the limit approaches. Okay, decreasing sets. So how we do this thing? Okay, let's understand here. We consider the example that x equal to n plus 1 upon n, where n belongs to capital N. Okay, so now we solve this thing. You get 1 upon 1 plus n. Okay, you get, when you solve this thing by mathematical or calculate the mathematical, you get this thing. Okay, so now when you consider n equal to 1 here, so you get 2, n equal to 2, so 3 by 2, n equal to 3, 4 by 3, n equal to 4, 5 by 4, n equal to 5, 6 by 5, up to so on. So here you can easily say that, the maximum value of the respective set is, this is the decreasing set. So maximum value is nothing but 2. So supremum of this respective set is 2. Supremum of this respective set is true. Okay. So what about the infimum value? You put the n tends to infinity here. So you get 1 upon 1 plus n, means limit n tends to infinity is nothing but your 1. So infimum value is 1. Okay, so infimum value is 1. So in this way you can see this, the respective sequence or respective set as the supremum and infimum value. Okay. So now another thing, increasing set. Okay, this is your decreasing set. Okay, now we are considering the increasing set, n minus n. Okay, increasing set. Let's suppose okay, n belongs to n. So now put the solve this thing. Okay, so 1 upon 1 minus n when n belongs to n. Okay, so now when you put n equal to 1, you get the answer s equal to 0. Let understand that. Put n equal to 1 here. You get set is 0, 2, 1 by 2, 3, 2 by 3, 3 by 4, 4 by 5 up to respectively. Okay. So here, what is the lowest value? Okay. So what is the lowest value? Is 0. So your infimum is 0. You can easily see that. But what about your supremum value? What is your supremum value? Put the limit n tends to infinity 1 upon 1 minus n. Okay, put the infinity here, you get the answer 1. Okay, so supremum value is 1. What about the infimum value? Infimum value is 0. Okay, so this is the basic thing regarding supremum and infimum. Okay, so what is a supremum? Supremum means LUB. What is the infimum? Infimum is GLB. Okay, infimum is GLB. So now strategy, trigonometric bounds. Okay, for example sin x. Okay, let's understand that sin x. Okay, so we know that sin x is always less than, means lies between 0 and minus 1 to 1. Okay, we know that the value of sin x, means range of sin x is minus 1 to 1. So what is the infimum value? Infimum means greatest lower bound. Greatest lower bound is minus 1. What is supremum means? Least upper bound is 1. Okay. So infimum greatest lower bound, supremum least upper bound. Okay. So now discrete periodicity. Okay. So let S is your sine n pi by 2, where n belongs to z. Okay. So when you consider that, so what is the lowest value? Lowest value means minus 1. Okay, let's understand that if z, for the value of z is integer, for value of n means your n is any number. Okay, when you consider that n is your any integer, means n belongs to z, your sign value must be must be -1, 1 or 0. Okay, -1, 1 or 0. Okay, when you consider, take any value of z and put down into the value of, instead of n, take any value of z and put down in place of n. Okay, you get means you get three values, -1, 0 or 1. Among the three values, you can consider that -1 is your infimum value, means GLB, and 1 is your supremum value, which is LU. Okay, so in this set we can consider that infimum value and supremum value both are exist in the respective set, but in the previous two cases, mean first two cases, either infimum or supremum may or may not be in the respective set. Okay, so how can we calculate this thing? Okay, so now compound trigonometric function here. Okay, so what about sin x plus cos x? So maximum value of sin x plus cos x. Okay, let's suppose a equal to, and x belongs to r for any real number. So what is the maximum value of sin x plus cos x? Okay, so let us understand x equal to pi by 2. That equal to x equal to pi by 2. So what is the maximum value? Means what is the value of this set? Is 1. Put x equal to 0. This is also 1. Put x equal to pi by 3. Okay, so sin pi by 3 means √3 plus √3 by 2 and 1 by 2. Okay, so √3 plus 1 by 2. Okay, so put x equal to pi by 6. So 1 plus √3 by 2. Put x equal to pi by 4. Put x equal to pi by 4. So this is nothing but your √2. Okay, so what is the maximum value here? What is the maximum value here? Maximum value is √2. So supremum of this value is √2. But when you consider that this is your always DC rule, if you have this is your √2, so another on the opposite side of √2 you get -√2. Okay, so what is the infimum value? Infimum value is -√2. Okay, supremum value is √2. So in this way you can consider that this is your maximum and infimum value. My dear students, you can also derive this thing by the, I think you know, their double derivative test. Okay, but this is a real analysis, and this is by the, you can solve this the infimum and supremum value by the calculation, not this derivative test, but you can also cross verify this thing with the derivatives, double derivative test. So now monotonic sets and limit. Okay, so let's suppose that set s is 1/1 plus n. So now put n equal to 1. You get the value 1, 1 by 2, 1 by 3. Sorry, 2. So 3 by 2. My mistake. Okay. So 3 by 2, 4 by 3, 5 by 3 up to so on. So here, what is the minimum value? Minimum value means infimum, means GLB. Okay. So my dear students, infimum means GLB. Okay. So what is your GLB value? Okay, GLB is nothing but your 1. What is your LUB? Means supremum value. You have to put n tends to infinity here. Okay, n tends to infinity here. Okay, so when you consider that n tends to infinity here, okay, you get, okay, sorry, this is my mistake, this is mistake from my side. Okay, so when you consider that n equal to, okay, so when you consider n equal to 1 here, you get 2. So what is the supremum value is 2, but what about infimum value? N tends to infinity here, so limit n tends to infinity 1/1 by n is nothing but your 1. So GLB is your 1 and LUB is 2. So for this scenario, s equal to 4 plus 3 by n. Okay, so put n equal to 1 here, you get s equal to 7, n equal to 2, s equal to 11 by 2. Okay, so this is your, you can easily see that this is your decreasing series. Okay, this is your decreasing series. So supremum is 7. So what about the infimum? What about the infimum? Infimum value is 4 when you n tends to infinity. So my dear students, you can solve this thing by yourself. Okay, question I write for you just. Okay, so s equal to 1 upon 1 by 2 plus 1 by 4 up to so on. So I just give you answer. Okay, infimum is, okay, yes, okay. So infimum is and supremum is. Infimum is your 1, supremum is your 2. Okay, you can solve this by yourself. Okay, by yourself. Okay. So my dear students, you can also do this thing. Okay. So now go to the next thing. Okay. Okay. So here function is, let's suppose that. Okay. So here s equal to 2 raised to n when n belongs to n. Okay. So when you consider n equal to 1, you get 2, n equal to 2, 4, n equal to 3, 8. Okay. So what is the infimum value? Infimum value means this is the increasing. Not always, just I give you one thing that whenever you have the increasing series, your first value is your infimum, and when you have a decreasing series, okay, your first value is your supremum value. Here the decreasing series, I think this is your decreasing series. Okay, so first value is your supremum, but in the increasing series, first value your must infimum. Okay, so now this is your infimum value. What about the supremum value? You cannot get the supremum value on real line, but when you consider that it's an extended real line, then supremum is infinity. You cannot get the supremum value of the geometric series, means for the respective geometric series. So the geometric sequence, this is the respective geometric sequence on the real line is does not exist, but for the extended real line it must be infinity. So now oscillation sequence 4 minus 1 or minus 1 raised to n, okay, and n belongs to n. Okay, so now proof n equal to 1 here. So n equal to 1 here, you get 5. Okay, you get 5. For n equal to 2, okay, for n equal to 2 you get 4.33. For n equal to 3 you get 4.2, means it's a decreasing series. It's a decreasing thing. Okay, so what is your supremum value for decreasing thing? Supremum value is your first value, means 5. What is your infimum value? Okay, so what is your infimum value? Okay. So how can we find this infimum value here? Okay, let's suppose when you consider that here limit n tends to infinity means does not approach the right proper value. Okay, so here we have two scenarios. Okay, we have the two scenarios, odd and even. Okay, so odd thing. Okay, for odd, okay, you get 4 plus 1 by n, and for even 4 minus 1 by n. Okay, 4 plus 1 by n, 4 minus 1 by n. Okay, so when you consider n equal to 1, you get 5. When n equal to 1 here, you get 3. Okay, so make sure, let's understand that n equal to 1 here. Okay, so n equal to 1 here, you get 5. For n equal to 2, by default it's converted into this, you get 3.5. Okay. For n equal to 3, you get 13 by 3. Okay, for n equal to 4, it's a 15 by 4. Okay, so supremum value, so my dear students, supremum value is 5. What about the infimum value? Infimum value is 3.5. You cannot get any value less than 3.5. Okay, and you cannot get any value less than 3.5. So your supremum is 5, and what is your infimum? Infimum is 3.5. So now what about this? If x belongs to q plus x square less than 2. Okay, so for the real number, q is your real number. Okay, so x square means either minus root 2 square is 2, either plus root 2 square is 2. Okay, so infimum value for the real line, I am considering this for the real line. Supremum value is root 2 and infimum value does not exist. Okay, my dear friends, I repeat one thing. For the real line, supremum value is root 2. Supremum value is root 2. Okay, what about the infimum value? You cannot get the infimum value. But you can get the infimum value on the extended real line. Okay, you can get the means extended real line. Okay, which is nothing but here we are talking about q plus. Okay, but what about the only x belongs to q? Okay, you get the minus root 2 and root 2. Okay? But we have the set difference. Here the set is q plus. Okay, q plus. For the q plus, supremum value is root 2. We cannot get the infimum value. But for only q, you get the infimum value is minus root 2 and supremum value is root 2. Okay, so this is the thing. Okay, for to find the supremum and infimum value. Okay, for this thing, supremum is does not exist. For supremum is does not exist in q. Okay, but for the real line, it's a simple table. Okay, so now it's a component axioms. Okay, it's a irrational void and it's a irrational void. Okay, this is for the, let's suppose this is your 0, this is your from negative side, this is the positive side. Okay, so minus root 2. Okay, so minus root 2 and this is your plus root. When we are consider the x belongs to R, okay, x square is less than 2. Okay, x square is less than 2. Okay, so supremum value is root 2 and infimum value is minus root 2. Okay, yes, it is not in this set, but it maybe it is exist. It is exist. So it does not that like that. It does not like that every supremum and infimum both value are exist in their respective set. It's a not thing. Okay. So my dear students, this is all from my side. If you have any query, any doubt regarding the particular session, please feel free to comment on this video. I will definitely reach out to you to solve your all doubts as soon as possible. So my dear students, this is all from my side. Thank you.